Okay, we're going to continue on with part B of the question. So let's first read the question. Another particle Q moves in a straight line with displacement s meters and velocity v meters per second. Its acceleration is given by a equals negative v squared plus 4, and at time t equals 0, Q is at point O and has velocity 2 meters per second. So first, B1, show that velocity v at time t is given by this equation. So the only information we have is a equals negative v squared plus 4. So recall, a equals dv equals dt. So we can rewrite the equation as this. And we think, so how do we get to equation for velocity? Then we certainly, looking at this, we have to separate the variables, which because it's a differential equation. And so we get integral dv over v squared plus 4 equals negative integral dt. So how are we going to do this? Okay, so let's first do the integral on the left. We have to first recognize that this is actually one of these standard integrals from the data booklet, and you can see it comes in this form, right? Let's put them sides to do a comparison, and we can see that it's 1 over v squared plus 4, which matches this which okay, whatever, it matches the second form, right? So how are we gonna do that? We're gonna rewrite it as 1 over 2 arctan v over 2, as seen by the second equation on the standard integral part. And on the left side, we can integrate it and become negative t plus c. Okay, and looking at the equation again, we're gonna see that at t equals 0, q has a velocity of 2 meters per second. So once again, we're gonna have to sub in t equals 0 and v equals 2 to solve for c, and we're gonna get, because of this, c equals pi over 8. And to simplify the whole equation, you're gonna get arctan v over 2 equals pi over 4 minus 2t. Okay, and then what do we need to do? We're gonna just need to obviously simplify both sides and to single out the variable v in order to equate one side v into an equation. So first we're gonna tan both sides, which we will obviously get v over 2 equals tan pi over 4 minus 2t, and then we're gonna get v equals 2 tan, and then we can put this in the same equation, minus 8t over 4. So this will be the answer for B1, and this will be the equation for velocity. So moving on to B2. B2 says, show that dv ds equals negative v squared plus 4 over v. So let's see. A equals dv over dt, right? So what does that mean? It means that it can also be rewritten as dv over dx times dx over dt. And because you can cancel the dv's, dx, therefore you can get dv over dt. And recall dx over dt, and x obviously being displacement, so let me rewrite that to be more clear. So it's ds. Okay, so this is basically just v, right? So we can rewrite this as dv over ds times v. And what is the equation for a again? So a would just be negative v squared plus 4 equals dv over ds times v. And obviously dv over ds will just become negative v squared plus 4 over v. Right? Is that the... Okay. which is obviously the same answer as what they got. So B3, find, it tells us to find the distance traveled by the particle before coming to rest. Once again, we're gonna need we're gonna need to, find when v equals 0. So how we're gonna do that? So we're gonna write this equation down again, and we're gonna set v equals to 0, and what does t equals to? And with the GDC's help, we're gonna get when v equals 0, t equals pi over 8, which is 0.392 dot dot dot. Okay, and so we're gonna need to distance, because it's distance traveled, we're gonna need to put it as s equals, we're gonna need to once again find the area of if we were to draw out this graph, we're gonna have to find the area under the graph in order to find the distance traveled, as done in part A of the question. So we're gonna, and because t is pi over 8, we're gonna set the upper bound as pi over 8 and the lower bound as 0, and then we're gonna write down the equation 2 tan pi minus 8t over 4 dt, and then by GDC, we're going to get S equals 0.347 meters. And basically, this is just, this is a standard IB question. This is 20 marks. And once again, this is a kinematics question that, kind of encompasses everything for sketching graphs to differentiation and integrals. And yeah, so thank you for listening.